Hello everyone. Today I'm going to show you a demo of a DC generator lab. So we're going to do three things together. First, I'm going to show you how to couple the machines together. Second, I'm going to show you how to connect individual machines. Number three, we're going to do some measurement together. So the machine order will be from the power source. The next machine will be the DC machine because the shield is built here to separate the two machines. Okay, after the DC machine, then we'll couple the torque indicator, and after torque indicator, that we will have our AC machine. So we're going to use the flexible metal coupler to couple those three machines together. To couple the two machines, we need to check the two shafts first. So one side of the shaft, it only has a square hole in it, and another side of the shaft, it has a big opening in it. The process is, so when we use the coupler to couple them, so we put the shaft inside the square hole first, and then make sure the back is locked, and then swing it in to the shaft with a big opening. Again, put the shaft inside the square hole of one machine. Make sure the back is locked, and try to swing in. Now it's locked. Now we're going to connect the machines. So this lab will be the DC generator lab. So what we're going to do is we are going to connect the AC machine as a motor, which will convert electricity into mechanical power. The output of mechanical power will be the rotating of the shaft. Then the torque indicator is going to measure the torque of the mechanical power and also transfer the mechanical power further through the shaft to DC machine. And DC machine in this lab will be the DC generator. So the generator is going to convert the mechanical power into electricity. So electricity needs to go somewhere. Where does it go? Go to our load. That's why we put our resistors load bank right here beside our generator. Now we're going to connect our AC motor. So we connect the power source first. So first we need a three-phase power. So we use red, black, and blue for three-phase power. Okay? So these are our power source. So red, black, and blue. And now it's come to the machine. The real machine is down there, but for your convenience, you get all the terminals on the panel. So now we only need to connect to the panel. Okay, and that's the motor starter, remember? Okay, our power comes here. Red, black, and blue. And also we need a DC power for the field winding. So what we're going to do is red and black, same thing. Down here is the DC source, power source. And very, very important, ground every machine with green cables. See the green terminal? Ground it. And then use daisy chain, okay? Now the field winding of the AC machine. The way to connect the machine or any other electrical circuit is a good way to do that is follow the current flow. Okay, we follow the power source, come to the switch. After connect switch, the positive you come to here, right? And after here, you're supposed to go to the positive of the field winding, which is M1. Go through the winding, comes out of the M2. Where does it go? Go to the positive of the DC current meter, because this is a DC source, right? And from the current meter, where does it go? It will go to the rheostat. And from the rheostat, it will loop back to the source. So follow the current flow. Positive of the switch, M1, from M2, positive of the current meter, negative of the current meter, field rheostat, another terminal of the rheostat, loop back to the negative of the source. Now the three-phase stator windings. From the motor starts, this is where we get our power source. We go to the three terminals of the winding. T1 goes to T1, T2 goes to T2, and the T3 goes to T3. Now inside each winding, what do you do now? Okay, we have to connect those winding has two portions. We're going to short these two portions through a current meter. And the three-phase looks very complicated, but it's not. Why? You have three identical circuits. If you understand one phase, you do exactly the same thing for another two phases. Okay? So now for the second phase, do the same thing. Okay, all three windings individually they are shorted through their current meter. Now what we do, we're going to connect as Y. So the very last terminal, we short them together. Okay, three-phase winding is done. But the one thing we want to do is we want to monitor the voltage as well. So we have a voltage meter. We can connect it to one phase. Here, identical because it's shorted by one wire. Okay, the AC motor is finished. Remember, two circuits. One is a DC field circuit. The other one is three-phase AC windings. So we haven't learned AC motor yet, but if we follow those process, you can connect them and you can use it first. All right, to connect the DC generator, first, we get a power source for the field winding. Positive, negative, black. Go through the switch. from the switch, positive, again, follow the current flow. From positive, we go to field winding. From field winding, we go to the positive of the current meter, but a small one, 2 amps one for the field current. Field current. And from the negative of the field current meter goes to the rheostat. And from rheostat, loop back to the source. So that's the field winding. Again, follow the current flow. Positive, field winding, another terminal out, current meter out, rheostat, loop back. Okay, now the armature winding, this will be a generator, it's going to generate the voltage. So we're going to make use of the voltage. So what we do now is, A1, A2 is the armature winding, but we do use the compensating windings. Okay, we use the current meter, armature current meter, to loop it, to short it, sorry. Okay, and now this voltage, armature voltage, is going to be output. Where does it go? Go to the load. Now from the DC generator, the armature voltage, A1C2, that's the voltage generated. And now we're going to connect it to our load. 2 terminals of the resistance bank. Okay, we want to have more resistance available for us. We can put all 3 resistors in parallel. This is resistor number 1, resistor number 2, resistor number 3. And how can we change the value of the resistance? By turning on those switches. So we finish our connections. After you finish your connection, please let the instructor check your connection first. Make sure everything is good, is safe to run. And then the instructor will unlock the power source and pre-run it, make sure everything is working, and then we'll hand it over to you. Now we're going to do some measurement together. To start the machine and do the measurement. Okay, the first thing to do is energize the power source. So every single time before we turn on the power, I want to monitor something. Use a multimeter. For example, I want to energize the AC voltage source first. So what do you do? You're going to use a meter, put in the AC voltage high enough. So here's the phase voltage, 120, 120, 120. I want you to be able to put the voltage good enough for the 120 and for 3 phases. So when I power up, my eyes monitor voltage. When I see the voltage around 120, for example 118, 121, 22, in the right range, it's okay. And I check another 2 phases. If it's not, what do? Turn off right away. Don't wait for the accident. Okay? For example, now I power up. I see 119.7, good enough, first phase, and I'm going to check the second phase. Same thing, I'm going to check the third phase. Same thing. So my 3-phase power is good. So now I'm going to energize my DC voltage. Same thing again, I'm going to put my voltage meter to the DC voltage, and DC voltage 125 volts. What I do is I set it as a 200 volts range, and then I monitor it. When I energize it, my eyes look at the meter to see I have a right voltage. I get 128 volts, roughly correct. So supposed to be 125, but because it's without load, a little bit high, it's fine. Okay? Energize the power to monitor the meter. Okay? Monitor your meter. Now we're going to start an AC motor here, the synchronous motor. So to do that, first make sure the shaft is clear. No cable, nothing is tangled into the shaft. Okay, when it's running at high speed, it's safe. Okay, now before you start the motor, follow my procedures, right? I'm going to show you. So before you start the motor, make sure you set your field current about 1.2 amps, the field current, and turn it off. Turn it off is very important. So set 1.2 amps, but turn it off first. Okay? And now why? We're going to explain it later. Okay? Just follow my procedures carefully. So now next step, everything is clear. Push the green button of the motor starter. You're going to hear the motor start running, and you're going to see those 3 current meters is going to crank, and it comes back. Basically, it's finished startup. And after you finish startup, when the current comes back, then you turn on the field current. All right, let's do it. Okay, finish the motor start. Now we're going to start the DC generator. What you do is, you turn on the power for the field winding. You're going to see the field current. Now it's adjusted. Now we're going to run some measurements. Turn on the field current. Adjust it. About 1.1 amps. Okay? And what are you going to measure? You're going to measure the torque in Newton meter. You're going to measure the speed. You're going to measure the voltage and the current. Now how can we change the current? By adjusting the load. Okay? So let's do this step first. Can you record? The torque is 1.65 Newton meter. Speed is 1800 RPM. Okay? The voltage is 145.1. And the current is 0. Basically 0. Let's call it 0 amp. Okay? Now we're going to move to the next point. How can we move to the next point? We're going to add load to it. Okay, this is our next point. The torque is 3.3 Newton meter. Speed is 1800. The current is 2.2 amps. Voltage is 143.6 volts. Now we move up to the next point. Can you report another point? Torque 4.72 Newton meter. Speed 1800. Current 4.3 amps. Voltage 142.3 volts. Next point. Okay, voltage 141.1 volts. Current 6 amps. Speed 1800 RPM. Torque 6.14 Newton meter. Okay, next point. Voltage 139.6 volts. Current 8.3 amps. Speed 1800 RPM. Torque 7.79 Newton meter. Okay, the last point. Voltage 138.4 volts. Current 9.9 amps. Speed 1800 RPM. Torque 8.97 Newton meter. After you finish your lap, so let your Sure, turn off the power first, and then let your instructor to check your data. Everything's good. Then you can come back, tidy up the stations. Okay? Sort out the cables according to the pictures at each bench. And also decouple the machine, put the machine back in the position. And then ask the instructor to check it and then sign you off. Then you can leave. Very, very important safety measures. You need to wear safety glasses and the face mask all the time during the lab hours. Today, because I need to talk, that's why I didn't put the mask on. But for you, you have to wear the mask all the time. All right?